Bismillahirrahmanirrahim. Welcome to geometry. Today, inshallah, I shall define for you some basic geometric terms. And we shall begin with this right here. That's a point. I'm going to call that point A. Now, points in geometry are labeled with uppercase letters or capital letters. So you use capital letters or uppercase letters to designate the names of points, because if there's more than one point, we want to refer to them and we give them different names. So here's another point, we can call this point B, and here's a third one, we can call this point L. I don't know, we can put another one here, and let's call that point M. So points in geometry have no dimensions, that is, they have no length or width. They're tiny little things, so to speak, they're imaginary tiny little things. They have no length or width, they're dimensionless, and they are designated with capital letters, or they're named with capital letters. Now, what I've drawn for you over here is a segment. That is, it's a little piece of a line. And a segment has two endpoints, has a beginning and an end, so to speak, but they're both called endpoints. So that's here, those 2 points, they're called endpoints. And segments are also given names here. And the segments are given names using their endpoints. So this is segment A, B, like this. Okay? So you can name segments using their endpoints. Now, we also just write segment AB. So if you want to say segment AB, you just write AB with a little bar on the top, designate that you're talking about segment AB. And also, the same segment can also be written as BA. In other words, AB and BA refer to the same segment. It's like first name, last name, first name. So there are 2 ways to name a segment. Now, here's another segment that I've drawn over here, and let's call this KL, segment KL. So I have here segment KL. But then I'm going to tell you that this segment KL is 5 centimeters long. I've given you actually its length. You know, it's a figure. It could have been centimeters or anything, but particularly I've given you here that it is 5 centimeters long. So we can say that the length of this segment is 5 centimeters. Now we say that by saying the measure of the segment KL, the measure of the segment KL is 5 centimeters like this. So this is a short way of saying the measures. The M here stands for measure. Okay. So the way you would read this is the measure of segment KL equals 5 centimeters. Now, this is still a little cumbersome for us. So instead of saying measure of KL, we simply say KL is equal to 5 centimeters. Now, you observe that here I don't have anything on the top over here. When I say KL like this, the way this is read is segment KL. But if I don't write KL and the bar over the KL, the way you would read that is the measure of the segment KL. Okay, I have drawn over here 2 segments, segment AB, and let's call this one CD. Now, segment AB and segment CD are of equal length. Let's call this one 6 units, and this one is also 6 units. In other words, their length is the same. In this case, we can say the length of AB, or the measure of AB, is 6, and we can say the measure of CD is 6, like this. Now, if you wanted to use this fancy terminology, you could say the measure of AB, like this, is 6, and the measure of CD, like this, is 6, the length of CD and length of AB. But it's more convenient just to write AB equals 6 and CD is equal to 6. Okay, so now you can see that they are of equal lengths. Right? So we say that these 2 segments are of equal lengths, or they are congruent. So we say AB is congruent to CD like this. Now this special symbol represents the word congruent. Okay? Now congruent in terms of segments means that they are of equal length. And the concept of congruency is a little bit more more refined than that. That is, it has more meaning behind it. But for the time being, we'll just say these two segments are equal lengths, so therefore they are called congruent. So when we say two things are equal, we use this symbol. So this symbol represents the word equal, and this symbol here with the squiggly sign represents the word congruent. So if two segments are of equal length, then they are congruent. So if two segments are of equal length, then they are congruent. Now, we can say AB is equal to CD. If you read this, the way you would read this particular statement, you would say the measure of AB equals the measure of CD, or the length of AB equals the length of CD. You would not read this as AB is congruent to CD. Okay, and you would not use the word segment over here in this kind of segment AB is equals to segment CD. No, this is the length of AB equals CD, or the measure of AB equals the measure of CD. Okay, so two segments are congruent if their measures or if their lengths are congruent. Okay, now here I have another segment, segment AB, and I'm going to put a point right here, smack in the middle of it, and I'm going to call that point M. And I'm going to say M is the midpoint. M is the midpoint of segment AB, like this. So M is the midpoint of AB. A midpoint is a point that divides the segment into two congruent segments. So midpoint is a point that divides a segment into two congruent segments, the two segments that are of equal lengths. So a midpoint is a point that divides a segment into two congruent segments. All right? That is, if this segment AB was 10, then these two baby segments produced, the smaller segments would be each of 5 units long, like this. So a midpoint is a point that divides a segment into two congruent segments. Now, we can say two segments are congruent. We can represent that by placing same marks like this on the segments. So here, to designate AM is congruent to MB, we can put one tick mark, or sometimes you can do two tick marks, or sometimes you can use any other similar symbol to suggest that the two segments are congruent. So we can say here is AM is congruent to MB. So the way you would read this particular symbol would be the segment AM is congruent to segment MB. The reason we know that is because M is the midpoint of segment AB. So a midpoint is a point that divides the segment into two congruent segments. Now, what I have drawn here is a ray. See, a ray has one endpoint. Okay, unlike a segment which has two endpoints, here we have segment A and B, and where A and B are two endpoints of the segment, a ray has only one endpoint, that is, has a beginning here, and it doesn't, and the other end, it doesn't stop. It keeps going forever to infinity and beyond. So here's a ray. It has a beginning, or has one endpoint, and it keeps going in the other direction infinitely. So that's very different from a segment which has a beginning and an end. And the way we name rays is by using the endpoint here and using any other point that's on the ray like this and putting a little ray symbol on the top. So the way you would read this is ray AB. So if I write like this, that's ray KL. That's how you would read that. And if I write this, that would be segment KL, and if I write this, that would be the length or the measure of KL. So as you can see, there is a different way of communicating different concepts. If you put that little symbol on the top, that's a symbol for ray. That's a symbol for a segment. And if you don't put anything, you're talking about the length or the measure of a segment. Okay? Now, let's say I have another point right here. Let's call that point C. Okay? And now I have this ray. I have ray AC. correct? But ray AC is this one. It starts here and goes this way, correct? And it goes forever. And then ray AB, which I have over here, it's the same thing. It starts right here and goes over there. So in other words, you can ray AB and ray AC are the same thing. Now, since rays go on forever, you can't really measure their length, can we? Because you have to have a ruler that goes on forever, I guess. But you can't really measure, so you can't say they're congruent. They're not the same thing. But you can say ray AB and AC are the same rays. They're just different names for the same ray. Let's put another point there. Let's call that one J. Okay? Here's another ray. Here's AJ. Okay? Now, AB, AC, and AJ represent all the same ray, and that's this one over here. Okay, so there are different ways of naming the same ray depending upon which point that you are given, if there's more than one point given. But notice that if you write this, okay, this is ray BC. The way you would read that is ray BC, but that starts here and goes over there. That's not the same. That's definitely not the same as ray AB, which starts over here. So ray AB and ray AC is not the same as ray BC. Those are two different rays. Got it? So you have to be careful when naming rays because you have to make sure that you begin the ray with the endpoint and go towards the infinity direction. So it's very important that you always begin with the endpoint of the ray. So ray AB and ray AC are the same, but ray BC is not the same ray. Okay? Now, the next thing we're going to talk about is this right here. Now, this is a line. A line is like a double-ended ray in a way, okay? So I have 2 points over here, point A and point B, right? They're on the line, and A and B here are on the line, and you can say this is a line AB. And very intuitively, that's how you write that. So if you're given something like this, you would read this as line AB. And if you're given like this, you would say this is line JL. That's how you would read that. That's how you pronounce that. So line AB, another way of writing the same thing is line BA. So line AB and BA are the same thing. You can't say the two lines are congruent because they go on forever. It doesn't make sense, right? So AB and BA are the same line. Now, if I had another point over here, let's call it point C, you could name the same line using this. You can call it AC, and it would still be the same line. And you can call it BC, and that would still be the same line. So there are many ways that you can name this particular line, given which point you choose, and they would all be correct. Okay? Now, another way of naming lines is using lowercase letters, like this, L. All right, so you can say you can name this line using lowercase letters, and you can say this is line L. So as you can see, we use lowercase letter to represent lines. So anytime you see lowercase letter in geometry, you don't think about points, you think about lines. So I have line M, and points C and D are on line M. So if I were to draw this out, I would first make a line, and I would label this line M. That's the name of the line, because you can use lowercase letters to label or name lines. And then I'm told that points C and D are on the line, so I put them in there. How far apart they are, I don't know. I'm not told, but I'm just putting them there like this. Lines, points C and D are on the line. Okay? And you can name this line also, therefore, as line CD or line DC like this. So there are different ways of labeling lines. Okay, so here I have line N, and I'm going to place 2 points over here, points A and points B over here. Now, when 2 points are on the same line, you say they are collinear. L-L-I-N-E-A-R. Collinear. Co means the same, like, co-pilot, like they're together. So A and B are collinear. Points A and points B are said to be collinear. That means they are on the same line. Now, if I have a point over here, let's say point P, we say P, A, and B are not collinear. I mean, they are not on the same line. So A and P and B are not collinear. Okay, because A and B are collinear, of course, but A, P, and B, altogether they're not, because P is like sitting over there. They're not on the same line. Now, if I had another point over here, let's put point M over here. Now, then I can say A, M, and B are collinear. That means they are on the same line. So if points are on the same line, we say they are collinear. And if they are not on the same line, we say they are not collinear. Okay? All right, so far so good. Now, if M is the midpoint, we can designate this as follows. So now I have a segment. See, on this line, which goes on forever, I have a segment as part of the line. So there's a segment AB here that's on the line as part of the line, right? That's okay, because it begins here and it ends here, correct? So I have a segment that's on the line, and I can put these two tiny little tick marks there to suggest that AM is congruent to, I'm going to here, let's just put it BM like this. So these two segments are congruent, that is, they are of equal lengths. Okay? Now, I do want to suggest one thing. That is, if you are given a point like here, point M, and if you're not told that it's the midpoint, you cannot assume that it is the midpoint. That is, if looks don't matter in geometry. That is, you can't say, well, they look like it's like in the middle, so it must be the midpoint. No, what if the midpoint is like right over there, right? So you cannot say that M is the midpoint unless you're absolutely told. Or if you're given a diagram like this and you're given and those two marks are placed on the diagram. If those marks are placed, then the author is trying to tell you that those two segments are congruent. That is, segment AM is congruent to segment MB over here like this. Okay? So you cannot assume that a point is a midpoint unless you're told that it is a midpoint. Now, in this particular diagram, I have two segments, and these two segments are intersecting. Okay? That is, they're crossing each other, and they're intersecting at this particular point called point P. So segment AB and segment CD, they intersect, and the point of intersection is point P. So the point of intersection is point P. Correct? So these are called intersecting segments, and the point of intersection is point P. Now let me draw you another similar figure where instead of having two segments, I have this. I have one segment and one line. So this segment is segment AB, and this is line, let's call this CD. So I have segment AB, right? And I have line CD, and they are intersecting at this particular point, and you can call that point, I don't know, you can call that K, point K. So the intersection of the segment AB and the line CD is point K. Another way of naming line CD is, of course, line KC or line KD. Okay? So lines can intersect, segments can intersect, and line and segments can intersect also. All right, I'll give you another example. Okay, here's a segment, and I'm going to draw this particular figure, like this. I have a segment here, and then I have a ray. So let's call the endpoints of this segment AB, and then I'm going to call this here M, and then I'm going to call this L. So segment AB, I have here, and I have ray ML. So let's write this ML, ray. So AB and ML, and they intersect. Wow, where do they intersect? Well, they happen to intersect right here at point M. Well, that point happens to be also the end point of the ray, but that's fine because that's a point just like any other point, right? So AB and ray ML, they intersect, and their point of intersection is in fact the endpoint of the ray, and that is M. And let's say M happens to be the midpoint of AB, and we can designate that by putting those little two tick marks like that. So now we can say AM is congruent to MB. Another correct statement would be AM, the length of AM equals the length of MB, like this. So when we write this without a bar on it, we're suggesting again that refers to the length of the segment and not the segment itself. So this is correct. Segment AM is congruent to segment MB, and this is also correct, which means the length of AM equals the length of MB. A ray, of course, will not have a length because it goes on forever. Inshallah, we shall continue from this next time. Until then, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.